This is page 595, question number 11. So the solution curve for the initial value problem. So in this, you need to recognize this as logistic growth. In logistic growth, your population will be in front, and your population will be in parentheses in the form of a number minus the population, or 1 minus the population over some number. So you have to recognize this is logistic growth. And if you recognize logistic growth, you will know it's going to look something like this, where you have a carrying capacity that it approaches. So that's what you have to recognize. Bam. Now, looking at this, you should know your carrying capacity is 10. Because when your population 10, your growth is 0. So that's your carrying capacity. All this is telling you your starting value is 2. All that means is at times 0, your population happens to be 2. So that should have gone through 2. Okay, so maybe I can fix this graph a little better. I don't know. I guess I can. So we know we have to go through 2. That's about 2. Okay. The concave up for values near 0. You should know it's concave up, excuse me, up into the maximum growth rate. Excuse me again. The maximum growth rate occurs at 5. You should know that. So at this point is the inflection point. Before that point, the graph is concave up. After that point, the graph is concave down. So clearly, at values near 0, you are definitely concave up. Okay? In fact, how do you know that? Your starting population was 2. So you know this is 2, which is before the maximum growth rate. Concave up, that's true. Then you should know all logistic growth, they're always increasing. Know what the graph looks like. It never decreases, it always is increasing. So that's true. And then the line tangent of the curve where y equals 5, what's the slope there? What tells us the slope? The derivative. Well, this is the derivative, plug in 5. 1/2 of 5 is 2.5. So bam, that's true. So the answer is E.